What type of number is 64? Is it abundant, deficient, or perfect? Those are our three options. We need to support our answer by showing the math behind it. I don't want you to just take a guess, write it, and move on, okay? I need to see why you said what you said. So we need to look at the factors of 64 in order to determine what type of number it is. In fact, we need to look at the proper factors. Remember, you find the proper factors and you add them together. Let's say 64 is a big number to you, or maybe I give you something even bigger. Don't forget that there's a way in which we can see how many factors it has to make sure we don't miss any. And the way to do that is to do the prime factorization. 8 times 8, 2 times 4, 2's, 2's. So that's 2 to the 6th power is the prime factorization. And then the number of factors is the exponents plus 1 all multiplied together. Since there was only one prime that this was made up of, it's just 6 plus 1, which is 7. This is the first time I believe I've given you one of these where it has an odd number of factors. And that's because 8 is a repeated factor. These are unique factors that this theorem gives us. And when we're finding the type, we only want to put in one of those factors, all right? They need to be unique factors. So factors of 64, let's go ahead and write them out. 1 and 64. 64 will not count as a proper factor, but it's still good to have in our scheme. 2 and 32. 3 is a no-go. 4 and 16. And then we jump up to 8 and 8. But once again, it's singular. We don't have those repeats. So just one of those 8s gets counted as a factor. And that's why it was 1, 2, 3, 4, 5, 6, 7 factors, but really only 6 proper factors. So the sum of the proper factors is 1 plus 2 plus 4 plus 8 plus 16 plus 32, which is equal to 63. Ask yourself, does that mean 64 is abundant, deficient, or perfect? It's really close to perfect. If this had equaled 64, it would be perfect. But no, 63 is smaller than 64. Therefore, we have a deficient number. 64 is a deficient number.